So we're going to show you how to fill in the page 28 in your notes. This is using previous knowledge in the lessons that we did last week and the week before on the straight line. So what is in your notes page at the top of it, it says from National 4 you've seen scatter graphs. You don't need to worry too much about the scatter graph aspect. That's just a graph that's got a whole load of points that are going in a general direction, and there's a line that is drawn through the centre of all these points, and it's that line that's referred to as the line of best fit, and you're being asked to find the equation of that line. So in order to find equations of lines, we need to be able to get we need to be able to find the gradient of the line. We also have got two equations that can be used in terms of their format. There is either y equals mx plus c. You use that one if you know the y-intercept, and if you don't know the y-intercept, then the one you'd be using would be the y minus b equals mx minus a. If you've used the y minus b equals mx minus a, you need to simplify it. That means you need to multiply out the brackets, collect your terms, and get your answer to the form y equals mx plus c. And the last thing you need to remember about is if the letters on the graph are not y and x, then you must change the equation for these two new letters. So it's very, very important that you pick up on this, because if you don't pick up on this bit about the different letters instead of x's and y's, this will end up resulting in you losing the last mark when you do this. So let's have a look at the first example. So we can clearly see we've got a line drawn there, and you can see 2 points on that line. So I've written down here the points that you can see on that graph. Have this point here, which is on the y-axis, would be the point 0,3, and you also know the point 5, 11. So the first thing we want to be doing is we want to be working out the gradient. There is your gradient formula rather, in order to do this. So what we'll be looking for you to do is label your 2 points. That's why I wrote them down. So I'm going to say that that first point has got x. The first x coordinate, I'm going to label it as x1, and the second coordinate of that point we call y1. The second point, the point 511, I'm going to label it as x with a little 2 at the bottom. That's the second point with the x coordinate, and then the 11 is the y coordinate of the second point, so it's called y2. So now what I'm going to do is substitute into this formula, which means I'd be writing down that m is equal to 11 for my y2, take away y1 is the 3, and on the bottom I'm going to have the x2 is the 5, take away the x1 is 0. So I'm going to have 8 over 5, and there's nothing else I can do with that. I can't really simplify it. So that will be my gradient value. I've also written down here that I actually know the y-intercept. That 0,3 is my y-intercept, and what that helps me with is it tells me what's called the c value in my equation. So I'm going to be able to write down that c is equal to 3. So because I know the y-intercept, I'm using this equation here, y equals mx plus c, which means that I now can go on and fill everything in here. So I'm going to be able to write down that my equation would be y equals 8 over 5, then I've got the x, and then I've got plus the c value going in as the 3. However, remember that bit we highlighted about if the letters on the graph are not y and x, change the equation to these new letters. So on our graph you will see here and here, right, we've, instead of having x's and y's, we've got c and f. So that means that my equation now needs to look like this. So the x is where I've got the c, and the y is where there is an f. Everything else remains the same, so it becomes y equals 8 over 5c plus 3, and that would be my equation of my line. The last part of that question is that you're then asked to work out, find the value of f if c is equal to 10. So all you're going to do is replace the c in this equation. So we're going to have f equals 8 over 5. This is times c, so that's going to be times 10. I'm going to write my 10 as 10 over 1 like that. And I can do a wee bit of cancelling here. I can say 5 into 5 is 1, 5 into 10 goes 2. That would allow me to write down that I'm then left with 8 times 2 is 16 over 1, which is just 16, plus the 3, which means that the value of f should be 19. So that's kind of typical of an exam question. You might get a straight line graph like that. You write down the 2 points on that graph, and you first of all work out their gradient. If one of the points is the y-intercept, then you can write down a c value, and then you can use this equation here, y equals mx plus c. But remember, if the graph does not have y's and x's, has got other letters, right, then you need to make sure you put them in the right place and not the wrong way around. So be very careful, know which one we talk about, the y to the sky. So this one here, right, pointing up the way, and that's what you replaced with the f. So the second example on that page, and that's to find the equation of the line of best fit in terms of, and it even tells you what letters they want this time. So again, I'm going to label my points. So I've written them both down. So this is my first point here. I'm going to say that's my x1, y1. And then this is my second point, so x2, y2. Now I'm going to substitute in to my gradient formula. Right, so I'm writing down that m would be equal to, I'd have 22 take away 25 on the top, over 8 take away 2 on the bottom. 22 take away 25 is negative 3, 8 take away 2 is 6. That will simplify, and you need to make sure you do simplify to give you the gradient is equal to negative a half. So this time, neither of these points is the y-intercept. So when it's not the y-intercept, we need to be using the y minus b equals mx minus a. Now what the a and the b refer to this time is you choose one of the points from your line. It doesn't actually matter which. So we're going to use the point 822, and we're also using that gradient equal to negative a half. But I could have chosen the other point as well, but this is what I mean by the a and the b. Whatever point you use for the line, and you can choose any of them. So we could have done exactly the same with the other one. So now I'm going to go y, take away, replace the b with the 22, equals, and our gradient is negative a half, and we've got x minus the a value is the 8. Now one of the other things it told you in your notes at the top of the page was that you then need to multiply out this bracket and tidy everything up. So we would get y minus 22 equals negative a half x, and negative a half times negative 8 would be plus 4. Still not quite tidied up with this. I'd need to deal with this minus 22 here, do the opposite, add 22. So it's like changing the subject, rearranging it to tidy that up, and you get y equals negative a half x plus 26. Still not quite there yet. Remember the bit about the different letters. So we can see on our horizontal axis we have got R, so that's like going to replace the X, right? So instead of X we are using R, and instead of the Y we are going to be using P, right? So the Y to the sky bit, this bit up here. So we are using capital R and P. So we're going to have P is equal to -1/2 capital R plus 26, and that would be the straight line equation. You've then got this second bit, find the value of P if R is equal to 12, and so for that you would be saying P equals -1/2 times 12 plus 26, so that would give us P equals -1/2 times 12. You could do a bit of cancelling there, so you do 2 into 12, you get 6, so you get -6 plus 26, which is going to give us P is equal to 20. So I will be posting these notes as well as having talked you through it, so make sure if you complete your notes by next Monday.